The previous lecture we have discussed about the angle of declination. Now in this lecture we'll discuss about the angle of dip. Okay, now what is angle of dip? We'll first try to look at what is basically the angle of dip actually it means, and then we'll try to focus on finding the horizontal magnetic field. Okay, after covering these two topics, you can directly hit the numerical and solve the numerical, because this is the final idea to cover, and then you can directly jump over the numerical for the Earth's magnetic field. All right, let me zoom in a little bit of this particular diagram what I have drawn here, and as you can see, here you can see, so we have zoomed in a lot, and as you can see that this colorful lines are indicating the magnetic lines of force. For example, if I just give the arrow, because so we know that in the north pole the magnetic lines of force, they emit from the north pole and they terminate at the south pole. So the direction of the north pole, we know that, right? So direction of the north pole, if you draw here that sorry, this is so fat I cannot afford to draw any diagram over here. So as you can see, I'll show you here. As you can see, all these magnetic lines of force, I'm sorry. So all these magnetic lines of force, they are emitting from the north pole and they're coming to the south pole. All right, and this is not, it is written for the purpose of geographic north pole we are talking about, and we'll come back to here later. But whatever you need to understand that the magnetic lines of force, they will enter or they will converge at the south pole, and magnetic lines of force, they will diverge from the north pole, right? So if you just understand this point, then you know that if this is geographic, north pole, for example, if this is geographic north pole, then all the magnetic lines of force, they will come in this direction. Okay, so now you can ask me this question, that's that definitely, that if this is a north pole, so definitely the magnetic lines of force will emit from here, right? As it is very natural. But you need to understand one simple fact. The fact is that the actual Earth north pole, what we say that is north pole, there lies the magnetic south pole of the magnetic south pole. Actually there lies, for example, here in this picture you can see that this is north pole, right? So if I just erase this one, so this is north pole, right? We know that this is north pole and north pole of the Earth, and here it is south pole of the Earth. But actually the magnetic, that means the magnetic behavior, if you are talking about from the perspective of the magnetic behavior, then you'll be able to see that all the lines of force, they are getting inside in this pole. So when all the lines of force, they're getting inside, that means there only south pole lies in terms of magnetism, right? In terms of magnetism, right? So all that lines of force, they are converging at this particular pole. So that means this is basically south pole, magnetic south pole, in terms of the magnet we are talking about, right? And this one we call it the south pole of the Earth. But actually in terms of magnetism, we'll be able to see that all that lines of force, they are coming out from this particular surface. So that means there lies magnetic north pole, as this picture shows, right? The magnetic north pole lies at the south pole of the Earth. This is the conclusion. And magnetic south pole lies over the inside of the Earth north pole of the like north pole of the Earth, right? So this is how actually it behaves. So if you have understood this one, then you can easily understood this diagram showing this is north pole, right? So I told you this one is the north pole, and all the lines of force, they are coming and getting inside, because just inside of the north pole, the magnet, a large magnet, if you imagine a large bar magnet inside of the Earth core, then the the south pole of this large bar magnet reside just below this Earth north pole. So they are reverse basically. So you need to understand, you need to remember this simple fact that they are just reverse. In the magnetic south pole reside below the Earth's north pole, and magnetic north pole resides just below the Earth's south pole. So you can understand that why magnetic lines of force are going and getting inside here. All right, so if I now zoom in a little bit, then you'll be able to see that these lines of force are terminating at one particular point, right? So these lines of force are terminating right here. I can see one lines of force is terminating here, right, at the point A, one lines of force is terminating at the point B, one at the point C, one at the point D, one at the point E, all the stuff, right? So now if I want to find the value of the magnetic field intensity over the point A, B, C, D, E, then what I need to do, we know that if we understand the concept of the vector, we know that, so in order to find any vector, we need to draw the tangent at that particular point, right? So if I draw a tangent over here, okay, so I'm drawing a tangent. So let's say I want to find the value of the magnetic field intensity at the point C. So what I need to do, I need to draw a tangent over here, right? I need to draw a tangent over here. Now this tangent, so now this tangent of the magnetic field lines, it is making some angle with the horizontal on that particular plane. So this is making some angle, let's say for example, this is making some angle theta, okay, over here. And if this is making some angle, horizontal angle theta with the horizontal, then I can draw another vertical line, and this vertical line is basically making some angle with this particular B. So if the magnetic field intensity represented by the magnetic field lines here is B, so we can call it B cos theta, and this one B sin theta. We do not have any doubt about that because we all know the very basic of the vector, right? So this B cos theta is called the horizontal component at one given point, and this B is the intensity of the magnetic field at the point C, and theta is called the angle of dip at that particular point, or C, right? So angle of dip at C is, this is the angle of dip. This is the concept of the angle of dip in the large picture. So if we just come back and then decide how we can find the angle of dip, for example, if we have one compass, then how can we find the angle of dip? So let's come here. Okay, so we generally use this kind of compass here, right? So if we use this kind of compass, then you will understand very clearly how we can find the angle of dip. Okay, so for example, so here in this case, as you can see, there are two planes, they are perpendicular to each other. One red plane, which is horizontal plane, so I can write this horizontal plane, and this one is vertical plane. Okay, so now, as you know that let's say in your room, this compass is making some angle with the north pole, as you can see here, right? There is some angle it's making with the horizontal. So now this if this is the north pole and if this one is the south pole, so what does that indicating here over here? This indicates that the magnetic north pole lies in this direction. Okay, so what it indicates, that magnetic north pole lies in this direction over this plane, right? This is the direction of the magnetic north pole, right? If this this compass stops at this particular point. So now what I need to do, if I draw another angle, let's say for example at this particular point, this is the horizontal plane, and we have seen that the horizontal component here, this is basically the B cos theta we can get from this particular the deflection of the compass, right? So let me go back quickly here. So this one is indicating the horizontal component. Okay, so let me just quickly zoom out a little bit. So this one is this one, so B cos theta, right? This one is B cos theta. So if I now want to find the value of the B, then this B will lie in the vertical plane. So let's say this is the value of the B. Okay, this is the value of the B, and this angle in the vertical plane, this is called the angle of dip. Okay, here theta is equal to angle of dip. Okay, now this one is in the vertical plane. Obviously you can understand the point, this one is in the vertical plane, but the diagram what I have drawn here is not exactly right, because let me erase the yellow lines, or you can get the idea of how to find the B. Now, so if I have drawn this one, then I can also draw one vertical line over here. So let's draw one vertical line from this particular point, right, over this plane. So as you can see, this vertical line, let's say for example this one is yellow, and let me make it a little bit thicker. So yes, so now as you can see, this is b cos theta. So definitely, if I ask you what will be the vertical component, this one is b vertical, and this value is equal to b sine theta, as you all know. And this one is the horizontal component, that is b horizontal equal to b cos theta. But now the point is coming. So what is the value, what is the relation between the angle of dip and angle of declination, if you ask me? So now, as you can see from here, if I just draw another angle, right? So what is the angle I'm trying to draw now? I'm trying to draw an angle which is the angle between the earth magnetic field and the geographic magnetic field. Okay, and so geographic magnetic field, for example, because you know that when the compass is indicating this particular direction, that means the earth magnetic field lies here, right? So this is magnetic north pole lies here in this particular direction, and when so at this particular point, as you can see, that this is the magnetic north pole, because the compass is indicating the magnetic north pole direction. The north pole of the compass will indicate the magnetic north pole. So definitely the magnetic or geographic north pole should lie around here, right? So geographic north pole should be around here approximately, if you say that. So if you do that, geographic north pole is here. That means, so if I take the one line now, if I insert one line from the origin to here and make it a little bit thicker, so as you can see, this line is lying in the horizontal plane, in the rate plane, right? So this angle which is making with the horizontal, this angle phi is called the horizontal angle, right? So this phi is called the angle of declination, declination, right? So this is the basically idea of angle of declination and angle of dip. Okay, so as you can see from this particular diagram, this angle of declination is lying in the horizontal plane, right? And angle of dip, this is lying in the vertical plane or in the white plane. Angle of declination, that is lying exactly in the horizontal plane, and which is represented by phi. And angle of dip, which is lying in the vertical plane and which is represented by theta. And the horizontal magnetic field BH is represented by this B cos theta, and where the B is equal to the intensity of the magnetic field at that particular point, right? So this is how you can get the idea of the magnetic field lines and the horizontal component of the magnetic field, angle of dip and angle of declination. Now the point is that, so what is angle of dip? Basically, if you have one compass with you, can you measure the value of the angle of dip? If I ask you, you can pause the screen and you can answer me. And in my opinion, so you can basically find the value of the angle of dip if you have one compass. Now what you need to do, you need to just make this compass. Let's say, for example, if I draw the compass once again, so let's say this is the compass, right? And this is the horizontal, this is the orientation is the horizontal. Now if I make this compass vertical and make this hand in this way, for example, right? So this is the north pole, and this is the south pole, right? So if you do that, if you make this compass vertically in place vertically, then what will happen, then you'll be able to see that there is an angle which is this north pole and the south pole is making with the horizontal. You'll be able to see that. So if I draw another diagram, for example, if I draw another diagram, and if I would be able to see that the north pole, for example, here the north pole is going below the horizontal plane. If I see that north pole is going below the horizontal plane, we can call it that positive dip. Okay, now if the angle is going above the horizontal plane, or theta is going above the horizontal plane, then we can call it negative dip. Okay, so this is the very basic idea of the angle of dip and the angle of inclination. All right, so we'll catch on in the next class.